Hello, ladies and gentlemen, and welcome back. Root Beer here with question number 2 on our 2019 Galois paper. The hypotenuse of right-sided triangle AOB lies on the line with equation y equals minus 2x plus 12, as shown in figure 1. The legs of AOB lie on the axes. What is the area of AOB? Well, one of the nice things here is we've got a nice little right angle. The axes are perpendicular to each other. So if we could just figure out the base and the height, we could figure out triangle AOB's area. Okay, so this is a light bulb, but let's briefly show a little bit of work here. So minus 2x plus 12. So this is written in the classic y equals mx plus b format. And the b at the end tells you your y-intercept. So we get 12 here. So already I know the height. I think this was b and this one was a. Doesn't really matter. Okay. But how on earth do I find a? Well, it's on the x-axis, and that's when the y-coordinate is 0. So I'll just rearrange, and you can see x is going to have to be 6. So 6, 0 is the x-intercept, 0, 12 is the y-intercept, but we just care about the area. 1/2 base of 6 times height of 12, 1/2 of 72, 36. So the area is 36, and that's really all we need to do. As I say, it is a light bulb question. But the next two parts are written solution, and I assume they have to do with figure 2 and figure 3. B. A second line passes through O, the origin, and is perpendicular to the first line as shown in figure 2. So we have a nice little perpendicular, and then we've got the C. The two lines intersect at C. Determine the coordinates of C. Okay. So here's where we need to explain ourselves. So what I would probably start by saying is, I know the slope of AB is minus 2 because, well, they tell me the equation. Okay? Now, one of the nice things is, since OC is perpendicular to AB, the slope of OC must be negative 1 over the slope of AB. This is a nice relationship. Perpendicular slopes are negative reciprocals. So negative 1 over negative 2, the slope of OC is 1/2. Okay? Now I'm doing all of this because we're trying to find C, the coordinates of C. So I need to find the intersection of two lines. Well, here I'm starting to figure out what line OC really is. Okay, so line OC is y equals 1/2 x plus whatever its y-intercept. But O is on the y-axis, so the y-intercept is 0, because O is the origin, it's 0, 0. So OC has equation 1/2 x. So now I just need to find the intersection between minus 2x plus 12 and 1/2 x. So set the two equations equal to each other. Let's bring everything involving an x over to this side. Now we'll have to add on 2 to 1/2, so we'll get 2 halves or 2.5 or 5 halves. X is 12. From there we get multiply by 2 is 24, divide by 5. X is 24 fifths. So plug in to find y. It doesn't matter which equation you plug in to find y, they should both get you the same thing. So I'm just going to go with the y equals 1/2 x. And we'll get 12 fifths. Okay? And if you're worried you did the calculation wrong, double check. 24 over 5 times negative 2 is negative 48 over 5. Plus 12, well, that's really plus 60 over 5. And 60 minus 48 is 12. So we get 12 over 5 there. Just, if you want to double check. But putting it all together, C has coordinates 24 over 5, 12 over 5. Okay, so there we go. We explained how we got the slope. That was probably a mark. We found the x and the y. Those were probably 1 mark apiece. So, three marks there. Not bad. Not bad. A part probably worth 3 marks. I'm not entirely sure. But, okay, C part. A second line passes through the point D in the first quadrant, as shown in figure 3. Oh, sorry, the second line. The second line. So we're just continuing this line onwards. Points E and F are positioned on the axes so that DEOF is a rectangle. If the area of DEOF is 1352, determine the coordinates of D. Okay. So what can we do? Well, for DEOF to be a rectangle, we see that if D has we see that D has the same x coordinate as, which one was it? F. Oh, E. Sorry. And the same y coordinate as F. Okay, because if it's a rectangle, we get these nice little sort of perpendiculars here. So F's on the x-axis. We'll put E down here. Sorry, E's on the x-axis. F is on the y-axis. Maybe call F's coordinates 0F. So D is going to be at EF. Okay? We see the area of DEOF must be E times F. Okay? Because the width or the length here is E, and the height here is what we're calling F. Okay, so I just need to figure out the coordinates of EF, or of D, and get EF. But now I see how this relates to the area, because they do tell me the area. Okay, so this gives me a nice little equation. 1352 must be E times F. Fantastic. That's one equation. But one equation with two unknowns I can't solve, so we need something a bit more. Well, D is on OC, which has equations y equals 1/2 x. So F, the y-coordinate of D, must be 1/2 of E. So that gives me one equation, and pair it with this other equation. We see 1,352 is going to be E, and instead of a half, I write a half E. Sorry, instead of writing F, I write a half E. Now, if I multiply both sides by 2, I'll get a 4, a 0, carry the 1. I'll get 2704 should be E squared. And from there, we should be able to solve for E. So that's a little over 20. E should, I think 52 will do the trick. Let's just double check. Make sure I'm not misremembering my calculations. So 104, and then 0, carry the 1, 26, 4, 7, 0. Yeah. So E is 52, and so F would have to be 1/2 of 52, 26. And that's it. We were just asked for the coordinates of D. So the coordinates of D are, so the E first, the long part, 52, and then 26. And there we go. Okay. And just double check, that was all we were asked for. Determine the coordinates of D. There it is. We're done. And that's all three parts of question 2 squared away quite nicely. Up next is going to be question 3. So we'll take a look at that in the next video. Thank you guys so much for watching. I'll see you next time.